Welcome to Spring LIB.
So in this question, we have the earthquake, and in an earthquake, we have two kinds of waves. We have the P wave, and we have the S wave, and they travel at different speeds. And there's difference, like the difference between when these two waves arrive, will tell us where the earthquake happens, like where is the center of the earthquake. So right now we're assuming that the typical speed of P wave is 8.5 kilometer per second, and for S wave, it's 5.5 kilometer per second. So we ask how far did the earthquake occur if the station detects the arrival of these two waves to have 1.7 minutes apart. And the second question is one station sufficient to determine the position of the epicenter? So that is a question we can probably answer without doing part A right. The answer will be no, and we can talk more about this when we actually get to it. So firstly, they're 1.7 minutes apart. So the distance delta x between the epicenter and the station is equal to v1 t1 and v2 t2, because that's the distance traveled by the S wave. So we'll call it, or we can call it P wave number 1, S wave number 2. I can also call this VS, TS, or VP, TP. But anyway, it's just that the two waves have their own speed and travel at their own time, but they travel the same distance from the center of the earthquake to the station. So from these, we will be able to tell that, let's see, I will call S number 1 because it has a smaller speed. So we have T1 because it has a smaller speed, it takes longer to arrive, equals T2 plus 1.7 minutes, or let's try to use second. We time it by 60 to be 102 seconds. So we have V1 times T2 plus 102 seconds equals V2 times T2. And by rearranging this, we get T2 equals V1 over V2 minus V1 times 102 seconds, which is 5.5 kilometer per second divided by 8.5 kilometer per second minus 5.5 kilometer per second, 102 seconds, equals 187 seconds. And now we're looking for the distance, delta x. So delta x is, we already have T2, so let's use V2. V2 T2 equals 8.5 kilometer per second times 187 seconds. It's 1.1600 kilometer. So this is not enough to inform the epicenter because we only say this is a station. All we know is that the epicenter is this much distance from it. But if you draw a circle with a radius of 16 kilometers, that is to say the center of the earthquake could be any points around this circle. So this information alone is simply not enough. So how many stations do we need? The answer is we actually need at least 3 stations to determine the exact distance. So because assuming these are so if we know that if we only have 1 station, this is not going to work. If we have 2 stations, usually we will be able to narrow down the range. Say this station might find the epicenter is here, and if it's lucky and if the epicenter is exactly on the line along these two stations, then two stations will be able to find it. But most of the time, the epicenter is not on this line because it's too much of coincidence. Usually, these stations have their own range, and they will, if you draw a circle around each station, you will have two overlap. So you will have two potential locations for the Earth because both points have the same distance to each station. So even with two stations, you still cannot tell where the epicenter is. And that's when you need a third station. Usually with a third station, say if this is a third station, then you can tell, oh, it's this one. Or if the third station detects something like this, you can tell it's this one. But the point is you need at least 3 stations, most cases, to certainly tell that where the epicenter is.